Okay, good morning class. Here's my second video. Hopefully it goes a little bit better than the first one. Today we're going to be talking about the solubility tables, which you'll be able to find on the first page of your gold packet, I believe. Maybe it is the third page. I'm not sure what your packets are like exactly, but the laminated ones, they're on the first page. And basically these tables just contain guidelines for the solubility of common ionic compounds. So they are useful to predict whether or not a precipitate will form when two ionic solutions are mixed. Okay, so here are these solubility guidelines. Basically, these group 1 metals like lithium, sodium, potassium, etc., all the metals that are in the very first column of the periodic table, they're always going to be soluble. So when you put those into like polar solvent like water, they're going to dissolve. There's no exceptions. Same with ammonia, nitrate, acetate, hydrogen carbonate, chlorate, perchlorate. Those are always going to be soluble no matter what. The halides, not fluorine, but chlorine, bromine, and iodine will always be soluble unless it's with silver, lead, or mercury. So if you have a compound that's silver chloride, that's going to be insoluble. That will not dissolve in water because it's an exception. Now with sulfates, they're also going to be soluble unless they're with these exceptions. So silver, it's same as for the halides, and same with lead, but mercury is not an exception, and strontium, barium, calcium is an exception. So basically what this means, silver chloride, it's insoluble, but if you had sodium chloride, this will be a solid. When you put that in water, it will dissolve and we'll get sodium aqueous ions and chlorine aqueous ions. This one, when we put in water, will just stay as silver chloride. It won't dissolve, it will stay as a solid. Now this table is for all the insoluble compounds. So carbonate, those are always going to be insoluble unless you have the group 1 ions like potassium, lithium, sodium, or ammonia. Same with chromate, same with phosphate, same with sulfides, and then hydroxides are usually insoluble as well, unless they're with the group 1 ions or calcium, barium, strontium. Now, let's go through a quick example. So silver nitrate and sodium chromate solutions are mixed together. So we have two different beakers, one with silver nitrate, which is soluble, so we have Ag ions floating around, and nitrate ions, and they're completely aqueous. It's a homogeneous mixture. Then we have a second beaker. This one has sodium, aqueous ions, and chromate, which is CrO4 2-. Those are also going to be aqueous. Two homogeneous mixtures. And we're going to take these two beakers and add them to a new one. So now, what's going to happen when these two substances are in the same solution? Will precipitate form. So we have silver nitrate. Silver has a +1 charge, and nitrate has a -1 charge, so they're going to be in a 1-to-1 ratio. Silver, nitrate. And remember, this is soluble, so it's going to be aqueous. Then we have sodium, chromate. Sodium's a +1, chromate is a -2. So we have a 1, or I mean, since we have a +1 charge right here and a 2- charge over here, we're going to need 2 of these to cancel the charge. So sodium to the second, chromate to the first, and this is going to be aqueous. Remember, all the group 1 metals are always going to be soluble. So it will dissolve. Now we're going to have a double replacement reaction, so we're going to have the silver react with the chromate and the nitrate and the sodium. So sodium is the +1, so we put it first, and nitrate. A +1 charge, a -1 charge, so they're in a 1-to-1 ratio. And this is aqueous. We check our solubility tables. Group 1 metals are always soluble. No exceptions. Same with nitrate. And then we get silver and chromate. So we have silver, which is a +1 charge, and chromate, which is a -2 charge. So we have 2 of these. And is this substance insoluble or soluble? Well, we'll have to go check our tables. Chromate, always insoluble, unless with group 1 ions or ammonium. Well, silver is not one of the group 1 metals, and it's not ammonium, so it will be insoluble. So now we have a solid, a precipitate forms. Here is our precipitate form. So yes, a precipitate will form, and what is the name of it? Silver chromate. Sorry, first time I'm using this pen. It's a little difficult. Okay, there we go. So another example, sodium hydroxide and copper sulfate. I will let you guys try to practice the one by yourselves. So let's do it right now. And once you finish it, check your answers. See if you can have the same answer as me. Okay, so now we're going to have sodium hydroxide. Which is +1, -1, so they're in a 1-1 ratio. If we check our tables, sodium ions are always aqueous. Hydroxide ions are insoluble unless with the group 1 metals, or calcium, barium, or strontium. And then we're going to have copper that will have a +2 charge, and sulfate, which is a 2- charge. So that'll be in a 1-to-1 ratio. So we'll have copper, sulfate. And the sulfate ions are always soluble unless with silver, calcium, barium, strontium, or lead. So copper is not one of the exceptions. So this will be aqueous. It's soluble. Now we're going to take this one, and this one, and this one with this one. So we have sodium sulfate. Remember, the sulfate ion is a 2-. This is a +1, so we need 2 of these. And these are always soluble. This is soluble with some exceptions, but sodium's not one of them. So this will be soluble or aqueous when it's in water. And we'll get copper hydroxide. Copper is a +2 charge, hydroxide is a -1. So we need 2 of these to cancel out the total charge. And hydroxide ions are usually insoluble unless with calcium, barium, strontium, or the group 1 metals. So copper is not one of those exceptions, so it's a solid. Here's our precipitate. So will the precipitate form? Yes. If so, what is the name of the precipitate? Copper. Remember, we have to use our Roman numerals for those transition metals that have more than one possible charge, and sulfate. I'm sorry, I actually forgot to balance this equation. So remember, this sodium has 2 of them over here, hydroxide has 2 over here, so that means we need 2 sodiums and 2 hydroxides over here. So and we have 1 copper, 1 copper, 1 sulfate, and 1 sulfate. So now it's balanced. Our previous one I also forgot to balance, so here we go. we had 2 sodium ions on this side. That means we need 2 sodium ions on this one, which means we have 2 nitrate ions. And that means we need 2 of them over here. So we added 2 over here. That means we have 2 silver ions. So now we need 2. We already have 2 silver ions. So now this is our final balance equation for both of them. So don't forget to balance your equations. Remember, this aqueous means that it's soluble, it's dissolved. Then this solid, that's the precipitate that's formed. So, yep, this is what we're going to be doing tomorrow. So come to class prepared. I will see you tomorrow.